Hello everyone and welcome back to my channel. In today's session, we will be looking at your scenario based Docker interview questions with real world scenarios, and then we'll also look at solutions for these scenario questions. Now, whether you're gearing up for a job interview or you're just brushing up on your Docker skills, then you're in the right place. I already have two other videos where I have covered 15 basic interview questions for your Docker, and then the other video where I've covered 15 advanced Docker interview questions. If you haven't already looked at it, I will provide the link to those videos in the description section, and make sure you check that out as well before you come to this particular video. Once again, before I start off with the session, please don't forget to hit that subscribe button. So let's dive into this. The first question I have is, suppose you need to create a Docker image for a Python web application. How would you do it? How will you go about it? So when we talk about creating a Docker image for a Python application, we will need to first create a file with the name Docker file in your project directory. And then this Docker file will have all the instructions needed for running the Python web application. So it will contain the base image, let's say Python, the latest version. It will contain all of your application code. So copying all the application code into the image, and then we'll also be installing all the dependencies using pip, and then also making sure exposing all the necessary ports for the web server. So once you're done giving all the instructions for your Docker file, and once your Docker file is ready, we can start building the image by making use of this Docker build command. And then we can also tag it appropriately, and then we can push this image to a Docker registry for distribution. So if you want to share it with other people, we can push it, we can maintain it in a central repository. So essentially, we create a Docker file, we put in all the instructions, we build an image out of this using Docker build command, we tag it, and then we push it to a Docker registry, and then using that image we can start running your containers. The next question we have is, describe a scenario where you would use Docker's bridge networking mode. So the bridge networking mode is commonly used when you're running multiple containers. So let's say you have container 1 and then you have container 2, and both these containers are running on the same machine. And if you want these two containers to talk to each other, we can make use of your bridge network. So always your bridge network is used when you want your containers to talk to each other. All right, so like in this case, container 1 needs to talk to container 2, or vice versa. We can make use of your bridge network for that. So for example, in a microservice architecture, each microservice will run in its own Docker container, and the bridge networking will essentially allow these containers to communicate over a private internal network. So Docker maintains its own internal network, and if you want to allow communication between this internal network, we can make use of your bridge network for that. So this isolates your container from the external network and also provides you with a secure communication channel between your containers. So essentially, whenever you want your containers to talk to each other over a network, we can make use of your bridge network. The next question we have is, how do you handle persistent storage for a Dockerized database application? So for a database application that is containerized, we can make use of your Docker volumes to handle the persistent storage. So basically, if you want to make your data persistent, you can make use of your Docker volumes for that. So we can either create a named volume, or we can create a bind mount. This is where we'll be storing the database files outside the container. So essentially, under this, we won't be storing the data inside the container, we will be storing the data outside the container. We can either make use of your named volume, or we can make use of your bind mount for that. Okay, now this will ensure that the data persists even if we stop the container or if we delete the container. So whenever you want to make your data persistent, we can make use of your Docker volumes for that. So this allows for data persistence across your container restarts and updates, and also ensures that the database remains available and consistent. So essentially, we can make use of your Docker volumes for this purpose, where the data will be stored outside the container. That way, even if the container is destroyed, the data would always be available and it would be consistent for us. The next question we have is, explain a scenario where Docker Compose would be beneficial for managing multi-container applications. So in Docker, whenever we talk about running multi-container applications, Docker Compose is what we can make use of. So Docker Compose is mainly beneficial for running and managing a multi-container application. So such as, let's say you have a web application which has a front end service and you have a back end service. So if you want to run these two containers together, we can make use of your Docker Compose for that. So with your Docker Compose, essentially we can define your services, your networks, your volumes. All of these things can be defined within a file, which is a YAML file. So we can define all these instructions. And once these instructions are ready, we have this command called Docker Compose up command, which can create the containers for us. Now this Docker Compose, this mainly simplifies the management and orchestration of multiple containers. So whenever we are talking about running and managing multiple containers, we're talking about using Docker Compose for that. And this allows the developers to spin up an entire application using one single command. So let's say within this YAML file, I have an application with front-end service, I have an application with back-end service. I just have to use this command docker-compose up, and all these containers will start running for me with this one single command. So this makes for the development and testing workflows more efficient for me. The next question we have is, describe a scenario where you would use Docker Swarm for container orchestration. Now in Docker, whenever we talk about creating an orchestration, creating a cluster, we can make use of your Docker Swarm for that. So Docker Swarm is used for your container orchestration in scenarios where you need to deploy and manage cluster of Docker hosts. So basically you wanna maintain multiple machines, multiple hosts as part of your Docker. We can make use of your Docker Swarm for that. For example, if you have a production environment, so let's say you have a production environment and you have multiple servers running in this production environment, we can make use of your Docker Swarm to basically deploy containers across this machine. So this becomes our cluster, and to manage this cluster, we can make use of your Docker Swarm, and we can use your Docker Swarm to run our containers across these machines. Okay, so that's where we can make use of your Docker Swarm. Now your Docker Swarm, it also provides you with features of service discovery, load balancing, and rolling updates, which makes it suitable for managing production workload at scale. So whenever we talk about managing multiple machines and running containers across multiple machines in Docker, we can make use of your Docker Swarm for that. The next question we have is, how would you secure a Docker container to prevent unauthorized access? Now, in Docker, whenever we talk about securing your container, there are some best practices that we can follow. So one would be to use minimal base images to reduce attack surface. So have the least base image with the least configurations. This will help you to reduce the attack surface. Then make sure we are regularly updating the container images and the dependencies to patch vulnerabilities or any security vulnerabilities. Then also implementing least privilege access controls by running with non-root users, and then limiting the container capability. So wherever possible, run the instructions as a non-root user so that we are having very limited access. Then configure the network segmentation and firewall rules to restrict the network access. So if you have any sensitive services, you can restrict the access by making use of your firewalls as well. You can also make use of your DCT, which is your Docker Content Trust, and this will help us to verify the integrity and the authenticity of the images that we're using for the containers using cryptographic signature. So that way we are only using the verified images to run our containers. And then finally, monitoring the containers activity and then auditing the logs for any suspicious behavior. So these are some of the best practices that we can follow to secure our Docker containers. The next question we have is, explain how would you scale a Dockerized application to handle the increased traffic. So whenever you want to scale a Dockerized application, we can either make use of your Docker Swarm or we can make use of your Kubernetes, and this will help us to manage a cluster of container instances. So again, whenever we talk about running or managing multiple machines, we can either make use of your Docker Swarm or we can also make use of your Kubernetes, which will help us to manage a cluster of container instances. So we can also configure auto scaling policies, which will help us to automate to increase and decrease the number of containers. All right. So let's say, based on your CPU utilization or based on the incoming requests. So if you want to increase the number of containers or decrease the number of containers, we can make use of your auto scaling for that. And this will allow the application to dynamically scale up or scale down to handle the fluctuations in traffic load. And this will ensure that the application will always have optimal performance and resource utilization. All right. So we can definitely implement auto scaling based on, let's say, CPU utilization. That way, if the CPU utilization is high, more containers will be launched, and if the CPU utilization is low, the containers will scale down so that we always have the right number of containers to handle the traffic fluctuations. Next question we have is, describe a scenario where you would use Docker monitoring tools to troubleshoot performance issues. So, if there are any performance issues that you encounter with your containerized application, then we can definitely make use of your monitoring tools. So, we have tools like Grafana and Prometheus that can be used to collect your metrics and then visualize these metrics from your container. So, you'll be running your containers, and any metrics, any logs that are generated from the containers, we can visualize that by making use of your Grafana and Prometheus. We can also monitor your key metrics like your CPU utilization, your memory utilization, your disk input, output, and network traffic. And this will help us to identify any bottlenecks and any performance hotspots. So, where the performance is having an issue, where the application is not working as expected, we can monitor different metrics and get that information. So with this real-time monitoring and alerting, we can be very proactive to identify the issues and also make sure that we are resolving these issues, and this will ensure that the application is running very smoothly. All right, so that's basically how we can monitor the performance and also make sure we are solving the problems with the containerized applications. The next question we have is, explain how Docker health checks can be used to ensure the reliability of containerized applications. Now, at any point, if you want to monitor the container health check to make sure the container is working as expected or the application running inside the container is working as expected, we can make use of your Docker health checks for that. Now, these Docker health checks are simply your custom commands or scripts that we will be periodically executing on the containerized applications. Now, for example, it could be a HTTP request to a specific endpoint, or it could be a database query to respond to verify the connection and the response. So the health check could be hitting HTTP URL to get the response, all right, or running a database query to check the connectivity and also the response we are getting from the database. So by doing these regular health checks on the containers, we can make sure that the containers are healthy, and Docker can automatically restart or replace your unhealthy containers. Okay, it takes care of that for us. So this ensures the reliability and availability of the application. Okay, so that's why your health checks are very important, and it makes sure that the application is working as expected and we don't have any issues on with the containerized applications. The next question we have is, how would you securely manage sensitive data such as passwords and API keys in Docker containers? Now, whenever you want to manage sensitive data in Docker, we can make use of your Docker secrets management feature. So, Docker has built-in secrets management feature that we can use to maintain your sensitive data in the form of secrets. So, Docker secrets will allow us to securely store and also manage this sensitive information. The sensitive information can be your passwords, it can be your API keys, and also your TLS certificates, which are encrypted at rest and in transit. Now, these secrets will be accessed only by the services running in the Docker Swarm and are only available to your authorized containers. And this will help us to prevent any unauthorized access to your secrets data. All right, so we can make use of the built-in feature that your Docker provides to store your sensitive data in the form of secrets. The next question we have is, describe a scenario where you would use Docker's built-in load balancing features to distribute the traffic across multiple container instances. So Docker's built-in load balancing features can be used in scenarios where you have multiple containers running the same service, such as your web application. So let's say we have this web application. For this web application, we have a service, and then for this service, we have multiple containers. In this case of scenario, we can make use of your Docker's built-in load balancing. So by deploying these multiple replicas of the service or your containers across a Docker Swarm cluster, Docker will start to automatically distribute the incoming request among these container instances using round robin scheduling by default. All right. So this will improve the performance and the availability and also the scalability of your application by spreading the workloads across multiple instances. So instead of sending the load to only one container, we can distribute the load across multiple containers, and that's where we can make use of your Docker's built-in load balancing feature. The next question we have is, explain how would you perform rolling updates to deploy new versions of a Dockerized application without downtime. Now, whenever you want to perform rolling updates in Docker, we can either make use of your Docker Swarm, or we can also make use of your Kubernetes to orchestrate the deployment process. Now, let's say you already have a container which is running using a Docker image. Now you're creating a newer version of this image with your updated application code. Okay. Now, if you want to deploy this to your containers, you can deploy it alongside your existing version and then gradually shift the traffic from the old containers to the new container. So let's say this is the old container which is running on image version 1.0, and then you have updated this Docker image, let's call it as version 2.0, and then you'll create a new container. So this container will be running on version 1.0 and this will be running on version 2.0, and then we'll gradually shift the traffic from this container to the new container, and that way we are performing a rolling update. So this allows the application to be updated seamlessly without interrupting the user traffic and ensuring we have a zero downtime deployment. So that's where we can perform your rolling updates. The next question we have is, how would you configure logging for Docker containers to capture and analyze application logs? Now, whenever you wanna configure logging for your Docker containers, we can make use of your Docker's logging driver. So Docker provides you with drivers that we can use to capture the logs and also forward these application logs to centralized logging systems such as Elasticsearch, Fluentd, or Splunk. So we can get the logs from your containers and we can start pushing it to your third-party tools to store and then visualize the data. So we can also configure the logging driver in the Docker daemon or Docker compose file to specify the destination and the format of the log. So where you want to store these logs. This will allow the developers and operators to monitor and analyze the application logs centrally, making it easier to troubleshoot and gain insights into the app behavior. Right. So looking at these logs, we can always do the debugging and troubleshooting of the application to make sure the application is working as expected, and we can also get insights into the behavior of the application, and above all, we have a centralized location for all of your application logs. The next question we have is, describe a scenario where you would use Docker security scanning tools to identify vulnerabilities in container images. So, Docker provides us with security scanning tools such as Docker security scanning or third party solutions like Claire. And we can use this to scan our container images for any security vulnerabilities as well as your misconfiguration. So, making sure the container is secure and we're not exposing any sensitive information. All the scanning can be done by making use of your Docker security scanning tools. So, for example, before we deploy a container image to production, we can make use of this Docker security scanning tool to analyze the image for any vulnerabilities within the base image, the operating system packages, and also the application dependencies. So, making sure we don't have any vulnerabilities. Now, this will ensure that we are only using secure and compliant images to deploy the containers in the prod environments. And this will help us to reduce the risk of security breaches as well as your compliance violations. All right, so we can make use of your scanning tools that will help us to scan for any vulnerabilities and misconfigurations. That way we can be assured that we are using a secure image to run our containers, especially in the prod environment. The next question we have is, how would you implement backup and disaster recovery strategies for Dockerized applications? Now, whenever you want to implement backup and disaster recovery strategies for your containerized applications, then we can make use of your Docker volume backups, container image registries, as well as your cloud storage solutions. Okay, we can make use of any of these options to do a backup of your data for your disaster recovery purpose. And we can also regularly back up these Docker volumes, uh, persistent data using tools like Docker volume backup or container native backup solutions. Additionally, we can also store the container images in a secure registry such as your Docker Hub or AWS ECR, which is your centralized repository for storing our Docker images, and this enables easy recovery and redeployment in the event of a disaster. We can also make use of your cloud storage solutions like S3 buckets or Azure Blob storage to store the backup offsite for added redundancy and reliance. So we can resilience. So we can make use of these options, various options for data backup and disaster recovery. In case something goes wrong and we need to recover the data, we can implement these options. So there you have it. That brings us to the end of our Docker scenario based interview questions. I hope you found these insights valuable for your Docker journey. If you enjoyed this video, give it a thumbs up and please do subscribe to the channel. Hit that bell icon for notifications. Let me know in the comments section what other topics you would like me to cover. Thank you for watching and I will see you in the next video.